Hi, everyone. Good afternoon, and thank you all for joining us today. Today is the second masterclass in a masterclass series that we're hosting as part of the India Forum for Nature-Based Solutions. So we're a collective of research and practice organizations, and we're looking to understand how best to support the use of nature-based solutions and hybrid solutions in the urban context, specifically in India. And as part of this, we are running this masterclass to kind of build awareness around different examples of NbS that have been implemented in the country, particularly in that urban context. What are the lessons that have been learned? How could these potentially scale to other parts of the country as well? So today I'd like to introduce you to our speaker, who is Shilesh Hariharan. He's an architect and an urban planner. He teaches at the Academy of Architecture, and he's a practicing architect at his own firm. He's previously also done his master's from TU Delft in the Netherlands, and the major part of his study was on disaster and its implication on urbanization. He's also worked with OOS architects and urbanists and on sustainable closed-loop systems and their integration as part of the built and urban environment. I'm just going to turn off my camera. I think there's some issues with my connectivity. Coming back to Shilesh, he's since 2013, he's back in India. He's actively participated and worked with several organizations, including the Greater Chennai Corporation, IIT Madras, and a bunch of NGOs on various projects as well as research work. He's been part of many key urban studies and projects related to urbanization, migration. He's also worked on the restoration of key lakes in Chennai and in Tirunelveli. And one of the big projects that he's worked on that is the topic of today's masterclass is the City of Thousand Tanks. So the City of Thousand Tanks is a multidisciplinary team of experts from the fields of urban design, water management, social and cultural engagement, policy, and finance. And the focus is essentially on creating inclusive and robust solutions for sustainable water management in Chennai. I'm not going to go into more detail on this. I'm going to leave that to Shilesh to get into it. But just a quick, some housekeeping notes. The structure for today is essentially a presentation by Shilesh for about 30 minutes, and then we have 25 minutes for Q&A. We do have a Q&A, chat window for you to put your questions in. We'll bring it up for Shilesh at the end of the class, at the end of his presentation, and then he'll be able to answer your questions. So please do feel free to put them in the chat. And with that, I will hand over to Shilesh.
Yeah, thanks for the introduction. So I'll straight away get into the presentation. Just 1 minute. Share my is the presentation visible?
Yes.
Yes. Yes. Okay. So I'll start at the timer as well. Yeah. So I'm here to speak about an experience in looking at how do we find out we can have a sustainable future in managing water in specific to the context of City of Chennai. So this is the collective. So this is a larger umbrella project which we call City of Thousand Tanks, which was initiated by the Dutch government, the RVO, and through the City Resilience Network and with tie-up to the Indian government. This was first initially floated as a large international competition. They looked at 3 specific cities. One was Chennai in India, Khulna in Bangladesh, and Semarang in Indonesia, because all these cities have a unique history with water. The idea is how they have evolved with water, and water always had been an integral part of the urbanization and the way of life, societal structure and all that. So this came about as a competition called Water as Leverage in 2018, which as a collective we bid. So I represent the architectural practice here in India, whose architects and urbanists who are the primary architectural practice in the Netherlands. So we collaborated and we created the large consortium of experts who we thought will be able to look at a holistic solution for water. Now we won the bid. One of the 2 teams that won the bid, it's one City of Thousand Tanks and another one is RISE Chennai. And the objective was clear. How do you look at sustainable water management for Chennai? So the first thing that we actually did is that. So we kind of wanted to understand what has actually gone wrong in Chennai, because if you look at 2015, we had a phenomenal amount of flooding. 2005 was a major rain event. We had phenomenal flooding in the city. 2015 was again a major rain event. We had the flooding. Most of the city was submerged. And you can see in 2018, we almost came so close to a D-Day where water scarcity became significantly rampant, and municipal supply systems were drying out. All the sources of water that city gets, drinking water and potable water from, when water was drying up. And this was the question that we started off with. What is the reason that a city which is flooded at one point and the next 2 years you see it's come close to a point where it's gone bone dry? So this question so we wanted to understand holistically where is the problem. So if we looked at rainfall data of Chennai, we get about 1,200 to 1,400 bad years, maybe 900 to 1,000 millimeters of rain. And if we capture the water that is falling in the urbanized area of the city, we have enough water. We have enough water falling on our footprint to serve the residents. And if you look at the structure, aquifer structure, a larger share of the city has a clay barrier and a sand barrier and a shallow aquifer. So it is possible for us to recharge and hold water as a part of a landscape and retrieve it sustainably. Far more than that, historically, this is a part of the world where you don't have any perennial source of water. So you don't have rivers, you don't have streams. So you rely on the 2 months of rain that is going to fall from mid of October, let's say end of December or first week of January. So this 2 months gets the significant 75 to 80% of rain that falls in the city's landscape, and it falls at a very high intensity as well. So 2,000, 3,000 years before, there was a simple system of areas that the kings and the rulers of this land had envisaged them. So what they do is, if you look at this picture, so one side is a porous edge, another side where you see a ridge is a man-made bund. So along the contour of the slope, contour of the landscape, the contour here is exaggerated just to give a feel of the understanding, but it's quite shallow, quite mild, gentle slope. So this ridge, it holds water during rain, and it stops water from running as a part of surface runoff, and then retains it as a part of the landscape. And it is all ingeniously connected through a system of networks, which is called the system lakes or the Erie system, which passes the water like an ice tray from one to the other to the other. So by the time you see water coming down to the marshlands, most of fresh water is captured as a part of the landscape. And this water of significant volume is used throughout the year for irrigation, recharge into the aquifer, and sustainably taken up at the village level. Now, what we realized is, we get enough rains. We have a very conducive soil structure, at least most parts of the city. We have a historic system that has been functioning for more than thousands of years. Now, where did it actually go wrong? Because this is a root. Then the question comes up: what has actually happened? So the urbanization pattern in Chennai, these are all rough numbers. Through satellite analysis, GPS, we came to these numbers, but we can see a huge amount of impervious landscape that is being created as a part of the urbanization process. And the process of urbanization by itself is looked at as an extension. And for Chennai, for instance, we get supply of drinking water as far away as 250 kilometers. So water is pumped from there, it's brought into the city. Most of the water is consumed, discarded, partially treated, partially untreated. It's all discarded through rivers, lakes, and into the sea. So this system becomes a transition zone where resources are consumed and waste is generated. These two systems we found as fundamentally contradicting any natural philosophies, or it's in quite contradicting to any system that could coexist with nature. So this is where we thought, okay, the larger perspective of a linear process, a city which consumes resources and constantly generates waste, has to be relooked at it from the nature-centric point of view, where every component, every leaf that falls down from the tree is a source of another cycle of activities, it's source of another nutrient cycle, and then upscales itself into another natural system. So there's no waste. It's just that its context constantly changes in the landscape, and its function constantly changes, its physicalities and its ability to adapt itself to the requirement changes, and natural systems reconsume it to the full extent. So how would it possibly be possible for us to look at urban centers in this form? And that's where we came up with this vision. So we wanted to see how we can take Chennai from the kind of a transitory, consumption oriented, infrastructural centric city to something that kind of loops itself, something that kind of balances itself, something that produces and turns its waste into an asset, and constantly kind of finds way to decentralized manage its systems. And that's the larger model. So what we do, we thought, okay, well, let's come up with a water balance model, because water is always a balance. What falls down, how much you retain, how much you use, how much you kind of produce as a waste, how much you reuse. So we said, okay, let's look at a balancing model for water. What do we capture? What do we treat? What do we recharge? And when we put all these things together, we must be able to achieve this holistic vision. And that's where we came up with all these set of tools. Now, these tools are fundamentally measures that we thought would be able to integrate inside the urban landscape. And these were the nature-based solutions. And I will give you a larger context of the nature-based solutions, why we felt it was quite interesting, because nature does all the functions of cleaning, consumption of waste, and then transforming energy into various particles. But then it is also an integral unit which provides life, habitat, leisure, and all those things that makes it a very holistic solution. So nature-based solutions becomes an obvious part of any urban development, because this will be able to make our environments far more receptive to the requirements, and at the same time kind of make it a place where life also thrives in all forms. So you see a list of measures. So we said we will restore historic tanks, we'll look at new tanks, we'll look at urban forestry, we will look at renaturalizing canals and rivers, we'll construct bioswales to capture, treat surface runoff and recharge into the ground, constructed wetlands for treating wastewater, look at solid waste management, because that's one fundamental key area, and also look at coming up with norms and conditions where we look at adaptive construction. So buildings being sensitive to the landscape and being a part of the capturing mechanism themselves. How can we come up with bylaws that can drive these kind of systems? And we took up a couple of demonstrative projects, two visionary projects. They're not actually, they are visionary projects that we said, if at all, if it is done in this kind of a landscape in this place, it will cause such a large escalation of impact. But this is the motto. So you have collect, treat, recharge, water turns as an asset, and then you consume. The consumption again causes a treatment, and then collection, treatment, recharge. So it's a loop, the loop that we saw on the cyclic systems. And we saw this loop being decentralized and locally integrated inside the urban fabric could possibly transform the entire landscape of the city. So it could make it completely resilient, it could be completely sensitive, and at the same time sensible for human needs, human social conditions also. But we came to a point where we had to demonstrate what we are saying. So we are saying about NbS, we are saying about all these measures, but tangible results, tangible measures had to be given. So we set out to do a pilot with the support of the Dutch government and the RVO, and through the network of city resilience officer, Mr. Krish. So we reached out to the school. This is the Little Flower Convent at the heart of the city. So you can actually see the coastal line and the US consulate. It's the old part of the city. And this is a convent. It's about 90 years old. It was started by the Belgian missionary, and it serves giving education for children who are visually impaired and who have audibility disability. So we felt it was quite appropriate to do in a pilot here, because it serves a very needy client. And we also saw the site mimic the conditions of the city. So the photograph that you see on the left is what happens during summer. So the city is this convent is about 90 years old. So the landscape, it's a large piece of land, and the city around it has urbanized. One of the process of urbanization is the levels of the functioning surfaces are constantly going up when you're doing road, when you're backfilling and filling your property. So the surrounding areas around the convent have significantly gone up, making it a kind of a depression in the landscape. And the municipal systems, they don't, so the invert levels of the sewage lines are going significantly lower. So you can see pressure of the pumped sewage coming and backflowing into the convent during the summer. And this is a photo that is taken on 21 November 7th, when we had about 200 millimeter event in 24 hours and the entire campus was flooded. So they had to bring boats to save the visually challenged children. So you see both the conditions. Just like the city, this mimics the condition where they had the issues during summer and they had water related issues during the rainy season as well. So we said, fine, let's try to have a solution where we address the wastewater, at the same time capture as much as rainwater as possible. So we came up with this system. Now, this what I am going to explain is a bit technical, but then I'll try to make it as simple as possible. So the number one is the settler. The settler is nothing but a kind of a septic tank which captures all the sewage water through gravitational flow. The settler had to be set away from the installation because it had to be in the lowermost geography where we gravitationally collect all the waste coming from the blind hostel as well as the deaf students hostel. So we collected that and we had the primary settlement happening, and then we treated the clarified water through pumps to the anaerobic reactor, which is number 2, the circular tank. The circular tank has 6 anaerobic compartments and an anaerobic digester, and water passes through all these in a vertical flow. And from there, we had 2 constructed wetlands connected in parallel. So the water from the anaerobic reactor is pumped into these 2 constructed wetlands, and the final treated water actually comes down to the storage tank at 4. So this is the settler. You can see it's set in a place where you're at the end of the side where it collects. Then number 2 is the anaerobic reactor. It's a rectangular tank, but we made it as a circular tank, circular profile, because there is the kitchen of the school there. So we thought it will be a wonderful place where children can sit and gather and use it as a stage. And then the constructed wetlands, and then the water tank. And what we did with the treated water is we kind of created irrigation lines on the ground for about 600 square meters. And then we put drip irrigation lines. It's in wastewater specific drip irrigation lines through the crevice. And then we started recharging the water into the ground. And this is the treatment standards that we were able to achieve. So that is the raw sewage in 1 and 2, the clarified. And then you can see at 6 is the water that we took out from the tank. And this gives you a larger picture of the treatment that is just done through natural process. There is no active treatment systems per se here. And these are all the standards that we have achieved. So we had CPHEO standards as the benchmark, to which we have, this is again results from October. We have significantly improved on this because this was the first set of standards that results that we took, and this is what we impacted. So this was how this landscape was. So that was a hostel for the nuns, and we took this area because it was in the middle of everything, but then it didn't have much of a functional function or a purposefulness to it connecting the campus. We shifted it to this. Now it's a green lush zone, and we have such amount of life and activity happening here. So these are the 2 constructed wetlands. They are thriving in the water that we are treating. And you see the garden around it. This is where we are distributing the treated water. So have lush vegetation growing around it. And we did some temperature measures. Then in summer, there is a reduction about 3 to 5 degrees centigrade in zones right next to this. And we have a wonderful biodiversity that is growing. These are mongoose. They used to, because this is a large campus, there are these mongoose as a part of the landscape. Now they started moving into the constructed wetland. They are always around. It's a pleasure to see that we are sharing spaces with life form of all sorts. And we have created an environment where everybody feels included, even children, even animals. So, and we got it inaugurated. One, let's see, Mr. Hen Going, who's the water ambassador who was the water ambassador for the Dutch government, who initiated the water acceleration project. And then we see consul generals from the Netherlands as well as Germany, and the Minister for Municipal Administration, Mr. K. Nehru, who actually inaugurated the project last August 31st. And the teams photographed below. And this is the group of nuns who gave us the opportunity, and the RVO team and whose architects. So we also have a live monitoring system through which we are monitoring the wastewater that is coming into the system every single day, the amount of wastewater that gets treated, what is the level of the aquifer, in the recharge wells that we have. So I actually forgot to mention about the recharge wells. Oh, sorry. Okay, so we also did a recharge wells in collaboration with IIT Madras. So IIT Madras came up with a unique way of doing these wells where we had a larger catchment tank, and we did a deeper borehole which goes about 75 feet, tapping into the confined aquifer. So there are two aquifers. One is the unconfined aquifer and the confined aquifer. So we kind of created a deeper recharge well so that the effectiveness of the recharge structures improve. And we did them at strategic locations inside the campus, and they are producing good amount of results in terms of capturing water and recharging them at a faster velocity than what would have happened in a non-capture or a surface runoff condition. So this, now what we are looking at it is, now that we have demonstrated, we have the recharge wells, we have the constructed wetlands, and then we have swales which have integrated inside this project. Now we are seeing all these elements that we have as an expression of nature-based solutions being transported to the larger scale. Scalability is something that we are very much interested in, because at the end of the day, if you look at what we have done at LFC is a STP. So we are treating about 27,000 liters of water every single day. And we are doing it in such a way that it is right at the heart of the institution, where the sisters stay, where the kitchen is, where the Maria Grotto, where everybody in the institution prays every single day. And this is right there. It's a part of that landscape. So that's the greatest thing about nature-based systems. They can be integrated, even though they are at the core. If you look at it, it's an STP. But the very way it is functioning, the very nature used inside it, makes it a environment which creates lives and supports lives to thrive in its environment. So it is multifunctional. It is very much integrated as a part of the built environment, and it can be designed in any fragmented parts it's possible. So design, flexibility, freedom, accommodation, and making it an integral part of the built environment makes it a phenomenal solution to look at decentralized wastewater treatment. And this is where we are looking at. So what we are looking at is what we have done at LFC, can we scale it up? Now scale it up in all possible ways, to large systems, to small systems, to systems that are along the water body, systems that are inside institutions, systems that treat channels, canals, rivers even. And that's where we come to the larger vision that we are promoting now. We are in the process of applying for Green Climate Fund. And this is the Mylapore Heritage Project. So if you look at the temple tank, historically the temple tank is an inverted pyramid. So the objective of the inverted pyramid in Mylapore, the bottom of the temple tank is about 5 to 6 meters. Now, if you look at the aquifer in Mylapore, it's at 5 to 6 meters. The clay barrier of 5 meters is the temple tank cuts through the clay barrier and actually exposes the natural aquifer at the bottom. And the temple tank is an inverted pyramid, as I said initially. So it funnels water at higher pressure at the bottom than at the top. So historically, temple tanks acted as a very fast recharge mechanism for settlements. And because they are such important components of holding water and important components that provide water for the wells of the surrounding area, it was given that holiness. So it was made an integral part of the temple. It was prescribed, designed in such a way that there's a holy reverence to it, so that we don't abuse it and we kind of make it an integral part of society. So that's what I come back to. Thousands of years we have been able to manage water. I think in these densities, we have to relook at how we manage water and come up with new systems that kind of finds the old essence, but in a new form. So this is Mylapore tank, and it's about 130 million liters capacity. And this is another tank in the vicinity. It's about 36 million liters capacity. And there was one argument that we constantly came back to in an inner city area, in an urban dense environment like Mylapore. It's very hard to capture water. You will not find green spaces. So we did an exercise to understand where the green channels are and how much amount of green is available inside the urban fabric. So you actually see this parts are green. So you have the PSC near ground for people who know Mylapore. And this is actually the Ramakrishna Mutt. This is a parking area for a mosque, and these are all small pockets of spaces that are culturally integrated. And this is Buckingham Canal, and you have a large set of open spaces on both sides of Buckingham Canal as well. So there is space. There is a possibility that we can create green infrastructure that can receptively hold water and not let it run away as a flash flood. And we are envisioning Mylapore to be something that is something like this, that is quite sensitive to water, green, at the same time, what to say, it is porous, it captures water in all its essence, it recharges it, and at the same time renews the cultural value of a temple tank. These are all the SDGs that we see, because the very reason water as leverage came into picture, I still remember what Hent said. If you start working with water, you see that water has a capacity to touch phenomenal amount of domains of life. So if water is provided, somehow in economy is also taken care, sanitation is taken care. Equity also comes within the perspective of water, because water sharing fundamentally defines how societies work together. And so, and if you are going to design urban fabric which is sensitive to water, then you also have green along with it, and water becomes an integral way how you live. So by just using water as a tool to tweak how we work with cities, we feel have a phenomenal impact on the larger urban agenda itself. And these are all the things that how we visualize Mylapore could be. And could be so integrated, it still could hold water, it still could be porous, it still could be the existing physical structure as it is, but still be a completely different environment, a water receptive environment altogether. And yeah, we see this as an expansion across the landscape. It river sensitive programs where housing could be designed in such a way that they also kind of find a sensible way to manage water. And this is what we see. One, Mylapore is one. We already know there are about 53 historic tanks. If we kind of benchmark this and make it a design opportunity for all these tanks, we have a significant impact along the landscape. And that's the name that comes, 1,000 tanks. So decentralized systems integrated inside the urban landscape and scaled to whatever possible extent it could be, starts creating a dynamics which making the city far more receptive, far more porous, far more water resilient, far more drought resilient as well. And we have all these programs that we are thinking about, the canals, renaturalization of canals, how do we manage, how do we create new tanks, how do we create new detention parks during in the OSRs, open space reservation spaces, or in parks, where during the summer they actually function as social hubs. During rain, they become detention zones where they stop surface runoff or the flash floods that actually happen during rainy season. So this has the capacity to completely transform Chennai and make it phenomenally water resilient. So the idea is we have centralized water treatment systems which are functioning today. Try to augment them with decentralized wastewater treatment systems and capture mechanisms. So you slowly start plugging out every compound at a time, every institution at a time, every building at a time from the centralized system. So the urban densities which are significantly increasing can also be managed and can also be resolved as a closed loop system. So we are looking at systems which work hand in hand with the existing infrastructure, but at the same time, by plugging each and every individual component out of the centralized system, we are also increasing the resilience of the centralized system. And at the same time, we are increasing the resilience of the whole urban fabric as well. And this is us. We have been on streets, we have been on all possible venues explaining what we are thinking. And this is our proposal for the GCF, which has been approved by the government of Tamil Nadu. And it is somewhere in the lobbies on the national government where we are trying to see how best we can fast forward it being projected as a project representing the government of India to GCF funding. And we have also been working with a lot of children, because we also understand that their visualization of water and their ability to understand water, their ability to work with water has a significant impact of what is going to happen to the cities of the future, even Chennai. So we had this water ambassador program where we reached out to so many children who are living predominantly in low-lying areas, informal settlements right next to the water body who see the brunt impact of the excess of water and the non-availability of water. So creating awareness over there. We have been in innumerable workshops here in Singapore, across all parts in Delhi and other areas where we have been speaking the same thing. No, it is possible for us to envision a new urban fabric where water becomes an asset and an integral part of how we think and how we work. And this is last week, so 31st of August 2024. These are all GCC engineers. They are going as on a national program to the Netherlands, funded by the Dutch government, to understand wastewater management and NbS as well. So there, we thought first we will build a capacity about understanding nature-based systems and solutions at what we have done. So this many engineers from Greater Chennai Corporation actually participated, and this is a photo when we had a walk at 2:30 and they were actually taking a break at for about 15 minutes. So they kind of, it was quite a humid day because it had rained the previous day and there was not so much amount of air. But everybody kind of informally settled around the grotto where we had done the installation, very well shaded, quite comfortable. Until we called them, nobody really understood they had been there for 15 to 20 minutes. And I would like to close with this because this is the beauty of nature-based systems. I will come back to say it is again an STP at its core, but look at what it has caused as a transformation in its in the public space, how it has manifested itself, and how it is being sensible and sensitively designed to the landscape, and becomes an environment that people feel so comfortable. They are here for the first time. They were asked, and they came down after the session only at this point of time. So it was so natural for them, and they also felt it because we took the photo and asked them to reflect. They felt as if it was being with nature is something that every human being is comfortable with, and the more and more we integrate it as a part of our environments, the more resilient we become and the more healthy also we become. And we have been in all kinds of platforms. We have created a mascot called Tuli. We have done videos about what is the issues in Chennai and what were the initial understanding of water and how it has changed through urbanization. And this is us. So it's a team that is a mix between the Netherlands and Chennai. So the Netherlands, known for its capacity to manage water, brings its larger holistic global views. We at Chennai know the problems and the roots of our heritage and history. So by working together, we are trying to see how best we can find solutions for the larger concerns of water and precipitation that we are facing in the world. And I think this year we have faced more than 2 events, which is more than 90 centimeters in 24 hours. None of our cities have the capacity to manage it. Climate change is challenging the way we live lives. So we would have to relook at the way we do things, and we have to relook at the way that, we we function at the end of it. So I'd stop with that.
Thank you so much, Shilesh. That was, I mean, fantastic work, fantastic presentation of the work as well. I have a whole bunch of questions, but I note there are a few questions in the Q&A box. I'm just going to read some of those out. If you have any other specific questions, also please do raise your hands and we'll let you off. So these are a couple of questions from Sitaram Sharnangat from TNC. So he had a question on community engagement and how it's a key aspect of NbS, but sometimes working with urban utilities makes that difficult because they don't necessarily think of community participation. So in such situations, how do you really promote a water balance model based on NbS?
Yeah, so working with the community is always a challenge, and it's an ongoing process. There is never an end to it. There's never a set process to it. Just that when we started with, I can only tell the experience that we have from the engagement programs that we have and what we had at LFC. So when we started at LFC is a progressively built institution. So all the buildings, there are buildings which are about 80, 90-year-old. There are buildings which are about 10, 15-year-old. So the campus is not a master planned entity. It's just as they get funding, they kind of do blocks, and the ad hoc connections of sewage are done. And when we started working with them, we had tough time understanding the sewage network. It took us nearly a couple of months of every manhole being opened, and then which direction is being connected, which direction is blocked, understanding that. And when we started settling, we were doing the installation per se. We had a lot of sessions that we had to work with the sisters to understand what is going to happen, how is it going to work. And it's a constantly changing campus as well, because the sisters' requirements constantly keep changing, and their perspectives also, because they have, we did recharge wells. They saw funding come from another institution, so they did still copied what we had done and did few more recharge wells. But it's a constant engagement, because there were concerns initially raised that the blind children are walking through this landscape, how would it be? There are children who, where they are not used to this landscape, how do we actually acclimatize them? And there is an access ramp that we had done to ensure that vehicles can go to a stage on the ground on the other side. These are all things that we discovered as we started working with the sisters. They were not given to us as a list to design when we started. So it is an ongoing process. It is hands-on, and that's also another thing about NbS, because in STP you demarcate a zone, and that zone is predominantly off limits, and then somewhere at the rear where you kind of put it and forget it. But when it comes to NbS, you have the opportunity to integrate it in places where it could change the way we look at things and the change the way we live life, for which it requires massive amount of efforts, communication, clarity, going back and forth in design. All has happened. It's not been easy. I would say it's not at all been easy, but there's no other, I don't see another way around it. As the challenges come, we would have to sit at it. And there have been instances where we have re-looked at it from scratch. And we had to re-look at our decisions, look at the way we have designed. So yes, and we weren't, when we started the project, we didn't believe there would be so much amount of complexity in the sewer network itself. It was phenomenally difficult for us to resolve, but that's the challenge, right? I don't know. The challenge, the larger challenge, the larger the kind of satisfaction that comes out of it. When we see it, every time we present it, we're extremely happy. I don't know, I would have done this presentation now 100 times, but every single time I speak about it, it still feels, oh, we crossed that and we come here. It's very difficult to believe, but then yeah.
So while we're on the subject of the pilot itself, I'm just going to club a few of these questions together. So one is, why the school specifically? Were there challenges, especially around, potential odor concerns linked to an NbS treatment plant? And then in terms of the recharge structures, did you face any challenges? One, because of its being a coastal area and then having a, deep 75-meter recharge well. Did you have any issues around seawater intrusion, or even the fact that the depth might have, affected quality because of the lack of sort of natural filtration media? So yeah, I know you kind of grouped a few questions together, but
yeah, I didn't elaborate much more on the recharge well. I can do that now. So first to start with, what the first question was.
On the choice of the pilot, it's happening at the school, and whether there were any sort of reluctance around doing an STP.
Yeah, the pilot, as I said, the project was funded by the Dutch government. So we wanted to put it at a place where, one, it kind of tackled a challenge which is similar to what we are going to face out in the open, because we need to know where a place where we have issues during summer and during the monsoon as well. And we wanted to do it in a place where the beneficiary has kind of the ability to absorb it, because we saw so many children who are there. And by putting it over there, every single time they actually walk through it, there is something that's changing the perspective of what plants and how treatment system are there, immeasurable. So we felt this opportunity would be an ideal place to root the project, and that's why we chose that. And it's, and on the other side, it's also at the heart of the city, and it has the green space, and it's something that the city resilience network had worked with. So all these parameters gave us the opportunity to work here. That's one. And regarding the recharge well and the method of putting the recharge water through treated water through subsoil infiltration and the odor, we don't have any odor issues, because the settler is a sealed tank, which has its own ventilation system, which is also fitted with activated carbon. So and we are taking it until the roof of the building and exiting off. The same happens in the anaerobic reactor. We are taking we are putting a activated carbon filter and taking it out. The constructed wetlands are subsurface flow constructed wetlands. So we have 10 centimeter of media, which is always dry. So the height of the media is 75 centimeters. The water level is at 65. So we always have that 10 centimeter of media, which is always dry, and no mosquito or vector-borne disease spreading issues are there, and there's no odor. And the water that's coming into the final tank is actually treated. So yeah, we don't have any odor issues as well. So the odor part. Next, this was a demonstration project. So the one thing is we could have put an ultra filtration or UV filtration into the system, and then we could have actually used the water that comes out of the system for consumption itself. We could have put it into the building for dual plumbing, but the budgetary constraints, and it's an old building that we are working with, and dual plumbing requires a lot more investment and a lot more hindrance to the daily functioning of the institute. So we said, rather than kind of trying to repurpose water, we'll recharge it, because this is also one of our philosophies. There is, when you treat black water and you funnel it for consumption, culturally there is a resistance to it. There is a certain amount of there is this subconscious concern that runs in the background. So what we think as the larger picture of the water balance is to recharge the water into the aquifer, treat the water to the standards that is required, recharge it in the aquifer, and make it a part of the existing logic of consumption, which is extracting water from the subsurface soil and then consuming it. So it makes it a part of the existing logic. It also creates a balance in the amount of water that we are putting through the year so that we maintain the aquifer. And that was the reason that we went with recharge. And in this specific reason why we went for this distributed recharges, we wanted to green this area, and at the same time we wanted it to be we wanted to distribute the water in such a way that there is no stagnation or there is no kind of wet puddle that happens. So we put the recharge systems about 30 centimeters below the surface at 30-40 centimeter interval in a loop, and we used subsurface irrigation system, sturdy ones with flushing possibilities as well. And we distributed across this area, and we put plants, predominantly plants, mosquito repellent plants, or herbal plants. So it increases the aroma of that area and the natural landscape itself. And these two, and recharge well. So what we did for the recharge well is we had a tank capacity of about 7,000 liters to hold the immediate water that is coming in. We had prior filtration systems where we stop the silt before we get it into the recharge tank. At the bottom of the tank, we had a sand layer and a geotextile fabric before it actually enters into the slotted pipe of the deeper recharge. So the deeper recharge goes to the second confined aquifer and causes recharge. So there is a filtration system before water actually enters into the aquifer. And yes, coastal area, water table is higher, water table is about a meter or so here. But if you look at the catchment in any amount of rain, I'm not looking at a 100-year event. I'm looking at a 25 to 30-year event. Because 50-year event, 100-year event are very difficult to solve in one campus. Because it's massive amount of rain that is falling. And looking at one campus to solve such volume of water is not feasible. So 25 to 30-year event, the water does collect into the rainwater harvesting structures actively. And in a matter of 12 to 20 hours, the entire thing drains to a normal about 60 centimeters below the ground level. And that's kind of sustained. And we did the recharge wells exactly in locations where we found sandy aquifer. So through permeability test, we actually did the recharge wells. But again, budgetary constraints gave us opportunity to only intervene in few areas. But then the sisters found this idea being interesting. They got funding for it, and then they did a couple of more recharge wells. So the campus is becoming far more water resilient now. So I hope I answered all the questions, first.
Yes, I'm going to group a bunch more again, specifically around the scale up part. So I noted that, kind of strategically, you've looked at heritage as a space that next stage of the scale, because those are easier to, I think, access, and those are sort of protected areas, right? But you have to kind of deal with the a general sort of urbanization trend towards impermeable surfaces, sort of competing interests, for, say, transportation, which they'll always try to expand roads, for example. So how do you plan on taking it from this kind of heritage focused scale to the larger scale that you had mentioned of, a network of these different tanks?
Okay, so the heritage is one part of what we actually gave as a proposal. We had looked at 3 other conditions where we looked at a canal, urban canal, which runs through the heart of the city and has significant amount of pollution that's flowing through it. How we can re-naturalize the canal and kind of connect it to the urban fabric. That's one. We also looked at a low-lying, not informal, low-lying economically weaker section housing, and then it's right at the edge of Adair River, constantly getting flooded every year. How we can re-envision that environment, and also an economic hub like Coimbatore, where we can actually look at this kind of system. So when it comes to expansion and urban city expansion, the larger challenges in expanded areas, you always have the possibility to look at systems as we design. Inner city areas are the biggest challenges because they hold land at a higher value, and the existing infrastructure are not scaled to the extent of urbanization that we face today. And any kind of intervention is very difficult to fit into the available ROW, because ROW is already saturated with vehicle parking, pedestrian pathway, not so much carriageway for vehicles to go, infrastructure, lighting, and all that coming up. So the challenge why we took Mylapore is to address this challenge, because if we have the capacity to address it at such densities, new developments are always possible to effectively deal with. For instance, Chennai is now going from 1,100 square kilometers to 5,590 square kilometers. There's a regional perspective towards Chennai planning that is coming in place. When we are doing those planning, when we are going to look at those kind of extension areas, when we are going to look at those kind of infrastructure investments that are going to come, we can integrate NbS as a thought process at the very design stage. Then it becomes very effective for us to put all these structures or these nature-based systems at the core of what we are expanding into. So transportation projects, yes, we would. I think it's not something that I am saying new, because across Europe and across US and all the other countries, the suburbs have significant amount of swales, water recharges. Swales are nothing but you have surface runoff that is coming from the roads, which carry certain amount of inorganic load as well as organic load. So you have certain set of plants and filtration mechanisms before you actually recharge into the soil, so that you can reduce that pollution load to a desirable degree. So we can employ that, but it's just that how do we integrate it in the landscape? And in our climatic condition, we are going to have rains only 2 months a year. So 9 months a year, you're not going to have water running through these green landscapes. What actually happens to them? And how do we? That's where LFC also is important, because the LFC is green through the year. And we don't have to pour water. The 1 month or so when the children go on a break, we actually use the treated water or some amount of water to pour to the plants, because they need that water. Other than that, for about 10 months of the year, we don't need to. We only need to prune them and maintain them. So in our condition, grey water treatment becomes paramount, because for green spaces to exist as green, as lung spaces, you need consistent supply of water. So at least if we can use grey water for treatment, NbS systems can be designed for that. They will always keep the landscapes green. And we have enough grey water being produced, decentralized, we can treat them, we can capture them, we can put it as a part of whatever we are building. So it is possible, it is very much possible. And I think the challenge would be much not so daunting as we have to look at in the inner city areas than in the new expansions or larger urban development areas. It is possible, my belief.
Glad to hear that. Couple of questions, I think specifically on the data and analytics. One, sort of in terms of designing and identifying these blue and green channels, what kind of analytic methods have you used? And then for post-implementation, how exactly are you looking at sort of monitoring and evaluation, and what are the sort of indicators that you're looking to use? What is the framework essentially for reporting on the effectiveness of the solutions?
This is in relation to LFC or the larger vision?
I think both? Because I'm assuming one is going to kind of feed into the other.
In LFC, what we are doing is, in terms of the design, I gave you the logic. We wanted to keep it as a part where we wanted to change the way the built environment is and contribute back to the built environment. So the NbS was brought into the heart of the institution, rather than looking at the treatment system was brought at the heart of the institution rather than isolating it. That was the only logic, and that's why we employed a pump. We also put a solar panel so that we have produce excess electricity and we feed it to net metering. So the pump is also taken care in terms of looking at energy. In terms of data, as I said, we have two flow control measuring devices which telecast the data every 10 seconds at the inflow and at the outflow point. So we know how much amount of sewage that's come inside the settler and how much has come out onto the treatment system. And we have put up a VLC system with Hooter support and online integration. So if any of the system goes offline, we get immediate indication that the system is not functioning, so we can attend to it. We also put rain charge inside the recharge wells. We have put detectors to understand what is the level of water table, and we also put a rainwater gauge, rainwater gauge, so that we know how much amount of rain is falling and what is the direct impact on the recharge well. So the rainwater gauge came in just at the starting of this year. So during this monsoon, we will have far more better data to understand rain precipitation and its direct impact on the groundwater, at least at the campus level. Now, this is something that can be scaled up. The same system can be looked at a larger scale, monitored, centralized, monitored in a non-intrusive manner, and monitored in a cloud-based system, because the data directly gets translated to the Dutch office. So the whose architects will be able to see it right now, the amount of water that's gone from morning to now. And we also can see the dashboard. So if they see something, they kind of alert us saying that there's something out there. So it's that simple, and that can be scaled up for the city as well. So if we look at Mylapore, then we would need to understand how much water we are going to capture, what are the porous surfaces, and we might have to have flow measures. We might have to set in places groundwater recharge fits with these installations. So we can also predict to an extent if a rain event is going to be absorbed by the soil, because we do permeability analysis. So we have projection models. We know the saturation level in the soil. So as weather bloggers do right now, you see that you predict that is a rain going to come, then we can simulate all these measures to know how much amount of water might precipitate out, how much amount of water will add up to the surface runoff, and how much amount of water might be felt as flooding if the groundwater table is already saturated. So these are things that we can simulate. It's an endless possibility, but what we have demonstrated can be scaled up. Can be, because it's all small units, and it's like a grain in the sand. You put a lot of it together, it becomes the beach. So there's no rocket science in it. Simple.
And are these sort of low cost measures that you're using? Like, how expensive would it be to set up something? Like, how expensive was the entire sort of monitoring for just the LFC project alone?
The monitoring here is what it was a bit on the higher end, because we wanted it to be a model. We wanted it to be telecasted across our partners. And I would say, I don't have the exact numbers, but then we didn't compromise on the monitoring in this specific project because we wanted to use it as a model. We know we are going to present all these values wherever we go. So we had a digital dashboard. We have all these flow meters and all the data coming directly through SIM-based internet connection to a PLC. So we have invested in it. Not all projects need to do that. It depends on the scope and the need of the project. Here the need was demonstration. Here we needed robust results, and we now are testing our settler for 27 the water for 27 different parameters. Significantly, we keep the samplers, constant samplers for 24 hours, so that they constantly take sample every 1 hour. So we don't have a random sample at one point of time. So we know an average sample through the day. So that sits on the settler running for 24 hours. It sits on the anaerobic reactor, sits in the constructed wetland. So we take water from all of them, send it to the labs. So we constantly do it. The idea behind LFC is it being a demonstration, and it proves what we are seeing. We don't need to invest so much in all the projects. But if that is the case, yes, it is also possible. We have gone for higher end specifications for the monitoring system here because of the nature of it.
Right.
But
As a
it's not
pilot.
what is driving it. It's not what is driving it. That what driving it is the nature. The cost of maintaining the system, I can say, we got the system running in October 22. We started in September, slowly feeding the sewage 1,000 liters a day for 28 days, and we started it off in October 22, and we are 2 years now. We haven't don't have so much amount of sludge still in the settler. So the predicted interval could be anywhere 1 to 2 years. For the anaerobic reactor, every 3 to 4 years, we have to desludge it, and that too to an extent of about 20 centimeters only. And for the constructed wetland, the only thing that we do is we prune the plants. We prune the plants every 3 to 6 months based on growth. Now they're growing phenomenally fast, so maybe every 3-4 months we prune them so that there is enough growth always happening. That's it. That's why.
I note we're 4 minutes to go. I'm going to ask one last question. This is on the sort of economic case that, an example like this could build. I notice you're sort of monitoring a lot of the environmental outcomes when it comes to just helping cities make decisions around choosing NbS versus other kinds of solutions, and what the sort of life cycle cost of an NbS would be versus other solutions to say manage flood resilience or heat. How do you think there's an economic case here that you've been able to also make, and do you have numbers for it?
The economic case, the larger economic case for the argument is numbers that I don't have with me handy right now, but I told you the O&M for the entire project now. The O&M is just, we have one garden now, and the O&M that we project is about for gardening for all incumbent motor, if there is some rectifications that we need to do, some solar related fixtures that we expect about 10 lakhs a year. That too, we have kept a lot of margins on this. So that's the O&M cost for the entire project, because that we did. Now for a wastewater treatment facility which treats 27,000 liters a day, I don't know what is the cost that might be in a MBR or what it might be in a SBR, but this is what we have. And that primary cost is the primary cost of this is the gardener, because he has to come every day and then manage, not every day, once a while manage the plants and then prune them and just walk around to see if the system is running, and if there is anything in the issue in the hooter, he informs us. We also have the central system, but then he also keeps an eye on it. That's the only cost that we incur as far as O&M, and that's the asset of nature-based system, because the capex are comparable with the similar water treatment systems, but the OPEX is completely less. If you are able to integrate it inside the built environment, I think we, they contribute back to the community. They become an integral part of life, and they run with minimal interventions and maintenance.
Noted. All right. I am going to stop here because I know we're 2 minutes to time, but thank you so much. This has been a fascinating conversation. Thank you so much for giving us your time to do this today. There are a few additional questions in the chat, and if it's all right with you, maybe I can just pull them together in a document and share them with you, and we can write back to the participants later with the specific responses. But thank you all so much for joining us also today. This is a masterclass series, so we will be doing another class at the start of next month, in the first week of October. We're talking about sort of community-based models for NbS and ways to kind of finance community-based models as well. Separately, on the India Forum itself, we do also run a research program, and this year our topics are looking specifically at procurement for NbS, developing a guidance for procurement and ways that it can be made more friendly towards NbS solutions. And then also related to what we've been discussing today, just kind of understanding what some of the standards and baseline assessments could look like for NbS to kind of help decision makers around choosing NbS as a solution type. But I think, and my colleagues will put the link in the chat for the research program, so feel free to check that out. This is a recorded session and it will be available online. We will also share, Shailesh, are you comfortable sharing the presentation that was presented today?
I'll check with my partners and get back on that.
Yeah. Otherwise, all of the details are also available on the Thousand Tanks website, and we'll share the link to that in the email we send post the event. I mean, post today's class, and we'll keep you posted on the next masterclass and send you a registration link for that as well. Thank you so much for attending today. Thank you again, Shailesh, for a very insightful discussion. And we will see you all next month. Thank you.
Thank you.
Thank you so much.